Today we are talking to Michael Stephen for the Sustainable Agricultural Film Conference in Singapore. He was a member of the British Parliament where he served on the Environment Select Committee and was Parliamentary Private Secretary at the Ministry of Agriculture. He is now a Director of Symphony Environmental Technologies. Michael, can you begin by telling us a little bit about Symphony?
Yes, Symphony is a British company quoted on the London Stock Exchange, and it celebrated its 25th anniversary last year. And our mission is to use science and technology to solve environmental problems and to protect public health. Now, in the case of agriculture, our technology can be applied to make farming safer and more profitable for farmers and growers.
We have heard that Symphony scientists have developed something called D2W, which makes plastic biodegradable. Can you explain this?
Yes, D2W is the brand name of a master batch which we supply to the plastics industry. The factories put a small amount of it, usually about 1%, into ordinary plastic at the extrusion stage. Now, this has no effect on the plastic during its useful life. But if the plastic is discarded into the open environment, it will not lie or float around for decades. Instead, it will biodegrade much more quickly than ordinary plastic.
So how does the technology work?
Well, ordinary polythene and polypropylene will fragment quite quickly into microplastics if exposed to weathering in the open environment. But its molecular weight remains too high to allow bacteria to access and bioassimilate the polymer and clean it out of the ecosystem. So it can lie or float around for many decades. And the purpose of D2W is to catalyze the oxidation of the polymer and reduce its molecular weight in a much shorter time. And research at Queen Mary University London has shown that this can be up to 90 times faster. And this happens under the normal conditions found in the open environment. So it does not have to be collected and taken to a composting facility. All it needs is oxygen and bacteria. Now, of course, nobody wants plastic waste in the open environment at all. But whether we like it or not, a substantial amount does escape. And that is the reason why there's so much public concern about plastic all over the world.
You have said that ordinary plastic fragments into microplastics. But what happens to D2W?
Well, in the case of plastic made with D2W, the molecular structure of the plastic is modified by rapid oxidation so that it's no longer a plastic. It converts into a waxy substance, which is biodegradable. Now, the European Chemicals Agency was asked to study this in 2018. And they issued a call for evidence to which we and many others responded. And they also read the reports published by the European Commission. And after 10 months, they told the Commission that they were not convinced that microplastics were formed. Now, if the European Union's own experts were not convinced, I don't see how anyone else could be.
Does D2W plastic contain any heavy metals or other contaminants?
No, it's based on salts of manganese or iron, and it has to be tested according to the British standard 8472 or the American standard D6954, which require proof that there are no heavy metals or other contaminants. It's also tested according to the OECD standards to prove that there's no toxicity to plants, animals, or fish.
Will D2W plastic biodegrade if it gets into the oceans?
Yes, it will. The French government has sponsored a 3-year study on this, which they called the oxobio project. And the report was published in 2021. And it shows beyond doubt that it will biodegrade in the oceans. And to be quite sure, the scientists made some D2W plastic containing carbon-13. And they identified carbon-13 in the bacteria themselves, proving that the bacteria had actually bioassimilated the material.
So I can see that D2W was invented to deal with plastic which gets out into the open environment as litter. But if it does get collected, can it be recycled?
Yes, it can. D2W has been available now for more than 10 years, and thousands of tons of D2W plastic have been recycled. But we wanted to be sure about this, so we asked expert laboratories in Austria and in South Africa to do some in-depth testing, and they confirmed that it could be safely recycled, and their reports are on our website.
What happens if D2W plastic gets into a landfill?
Yes, we're often asked about this, but if plastic has been put into a landfill, it has been responsibly disposed of, and it doesn't really matter whether it degrades or not. In fact, it will degrade so long as it has access to oxygen. But landfill operators do not want biodegradation unless the landfill has been designed to collect the gases, which most of them have not. And this is one of the problems with the kind of plastic sold as compostable, because it generates methane in landfills, and this is a powerful greenhouse gas.
What is the difference between oxodegradation and oxobiodegradation?
Well, the only scientific definition is the definition given by CEN, the European Standards Authority, in TR 15351. And this says oxodegradation is defined as degradation resulting from oxidative cleavage of macromolecules. So this describes ordinary plastics, which abiotically degrade by oxidation in the open environment and create microplastics, but do not become biodegradable except over a very long period of time. By contrast, oxobiodegradation is defined by CEN as degradation resulting from oxidative and cell-mediated phenomena, either simultaneously or successively. And this means that the plastic degrades by oxidation until its molecular weight is low enough to be accessible to bacteria and fungi, who then recycle it back into nature. And D2W plastics are designed for oxobiodegradation.
How can farmers benefit from D2W plastic?
Well, farmers all over the world spread thousands of square kilometers of plastic sheet on their fields to protect the crop from weeds and to reduce the evaporation of water. But the problem with this is that when the crop has been harvested, they have to drag all this plastic off the fields and dispose of it somehow. It's not a good idea to burn it, because burning plastic generates some very nasty pollutants. And in some countries, this practice has been banned altogether. And burying the plastic is not a good idea either, because it's very labor intensive and effectively puts the landfill site out of cultivation. Some farmers do send their plastic for recycling, but it's usually contaminated with mud and other contaminants. So recycling does not make a lot of sense when you consider the cost of hauling the plastic off the field, loading a large truck, driving it along country roads to a recycling facility, often many miles away, using fossil fuels, causing congestion, and emitting pollution. Then when it arrives, the plastic has to be washed and the contamination has to be disposed of somehow. And the plastic then has to be processed into recyclers. I don't think this makes any sense in economic or environmental terms.
So what can the farmers do?
Well, fortunately, they can now buy mulching film made with D2W technology at little or no extra cost, so that by the time the crop has been harvested, the film will have become biodegradable. And the next time the field is plowed, the biodegradable material will be returned to the soil, where it will be bioassimilated by the bacteria and will provide a source of carbon for next year's plants.
This seems really useful, but will it work for different crops in different climatic conditions?
Yes, it will. We've done field trials where we've experimented with different formulations for the master batch, so that by taking account of the climatic conditions in the area and using the correct formulation, we can make the plastic last for as long or short a time as the farmer requires. And this can actually be a bespoke product. But this can't be done with mulching film made with bio-based plastics, which are in any event much more expensive and may not be strong enough.
Is it more difficult to spread D2W plastic on the field than ordinary plastic?
No, it's just the same. And actually, we've heard of a company in Ireland called Samco, who have invented a machine for laying the mulch film. They're selling the machines and rolls of D2W mulch film, not only in Ireland, but in other countries as well.
Are there any other uses for D2W plastic which would be helpful for farmers?
Yes, we can make silage wrap and baler twine. We can also make tree protectors for young trees, plant pots, fertilizer sacks, and export packaging for fruit, vegetables, and flowers.
So we have talked about biodegradable plastic, but have you done any work on insects, which can be a serious problem for people who live and work on the land?
Yes, we have. In many parts of the world, farmers use drip irrigation pipes made of a thin-walled plastic. And these pipes are laid just below the surface of the land, with holes in exactly the right places so that the water gets directly to the plants. But unfortunately, these pipes get punctured by insects, and much of the valuable water is wasted. So we've made plastic pipes with our anti-insect technology so that the insects are repelled and don't damage the pipes. Also, in some parts of the world, flies and mosquitoes are a serious problem because they spread disease. And we've thought about that, and we can make plastic sheets for use in farm buildings and in workers' houses so that the insects are killed if they come into contact with it. We also have a slightly different type of plastic which kills bacteria and viruses. And we've noticed that there are some crops, such as bananas, which are attacked by insects while they're on the tree. And we've developed special growing bags which will protect the fruit from these destructive pests.
Well, it's good to know that the work's been done in these really important areas. Do you have anything to offer to keep water pipes and tanks clean?
Yes, we can make plastic pipes and tanks with the antimicrobial technology so as to prevent the buildup of fouling by bacteria on the inside of the pipes and the tanks, and in plastic air conditioning pipes. And these bacteria, of course, then get into our drinking water and into our lungs. Because it's embedded in the plastic, instead of being sprayed or painted, our technology lasts for the lifetime of the pipes and the tanks.
Have your scientists developed anything else which would be really useful for farmers?
Yes, we can supply fire-resistant plastics and also plastic sheet for growing tunnels and greenhouses, which will not become brittle when exposed to sunlight. And these can also be made with antimicrobial or biodegradable technology if that's what the farmer wants.
Thank you for explaining all of this, Michael. Do you mind if people contact Symphony if they have an interest in using one or more of the technologies you have described?
No, they would be very welcome. They can visit our website, which is symphonyenvironmental.com, or send us an email. And we have distributors in 97 countries around the world. And finally, it's worth mentioning that all the technologies I've mentioned are available now at little or no extra cost as compared with ordinary plastic.
Thank you, Michael Stephen, for answering our questions today.